Next, we look into test automation technologies. Here is a figure of the testing process dimensions we have covered previously in this course. And what follows next mainly covers functional testing from the black box perspective on different levels, mainly at the system level, but also to some degree this can be exercised at the unit level as well. So black box functional testing technologies are covered next. And here we have the evolution of testing approaches. So we have recorded scripts, engineering scripts, data-driven testing, keyword-driven testing, and model-based testing. And as you can remember from the evolution of various other artifacts or areas like land transport, I'm not saying that those that are sort of on the higher level, 4 and 5, would be in all cases better than ones that are on sort of a lower level. So the level where you want to be is not that everyone wants to be in model-based testing. In some cases you might want to be in the recorded scripts level. Other thing I should point out that these are not specific tools or technologies in that sense. This is like a technology archetypes. So for example, there can be many different tools for model-based testing. They can be, with JUnit you can do engineered scripts or data-driven testing. And with Selenium you can actually do recorded scripts, engineered script, data-driven testing. And you can even plug it in with keyword-driven testing and model-based testing. So we start out by the recorded script. So what is the idea here is? Well, you use capture replay tools. And what the capture replay tools do is that they record users' actions to a script. So for example, all keyboard and mouse events are recorded. So the script accesses the user interface of the software and collects all these actions and different input fields and buttons and widgets that are accessed. And after the script has been recorded, it can be played back again, like a recording. And also one can do simple checks in the created script. So then one can actually edit the script code that is generated after the recording. One can do checks like whether text exists and whether objects are in the user interface and the data of the graphical user interface. Objects can be checked. So the good side of this approach is that it is relatively quick to set up when you capture your actions by recording them on the screen, and then you can just play them back. So there is no time wasted in programming the test automation. So not like you have done in the previous exercises where you have actually programmed the test automation. Here you simply record it. The downside is that they are very unstructured and they are sort of non-maintainable in practice. So if the system changes, they need to be captured again. And these tools have been around for a very long time. So this is from the Fusters and Graham's book from the 1999. And this sort of capture replay tool was already present at that time, but even during that time the expert considered that capture replay is not really a test automation. Well, of course it really is, but is it a good solution? Then I'm not so sure. There is currently Selenium IDE that you can also try out in the exercises to see if the recorded scripts are a good idea. So now we jump to the engineered scripts, and this is basically what you have been doing in the exercises with the white box and with the black box testing technique. So this is engineered scripts. So this is just like any other software development project. So you do some programming to do the test automation, and typically unit tests would be in the category of engineered scripts. So the scripts are sort of designed from the programming viewpoints. They are well designed, modular, robust, documented, and maintainable. There is separation of common tasks, for example, the test setup, teardown, error detection are in separate tasks. Code is written manually, and the implementation and the maintenance require programming skills. So this is unlike in the capture replay, where you can actually do something without programming. But the test data is still embedded into the script. So this is a 2013 study that compared implementing test automation using the two previously mentioned approaches: the recorded scripts, also known as capture replay, and the engineered scripts, which is basically programming the test automation. And what the study actually confirmed is that the initial development of the script with the capture replay is much cheaper compared to the engineered scripts. So they tested this out with Selenium in five different systems, and the development time for the web driver, which in this case refers to the engineered script, was 2.12 times bigger in Mantis system, and then in this project it was only 1.32 times. So this was 32% more expensive to do the engineered scripts, and in here it was 112% more expensive to do the initial test development. However, they also studied the evolution, and during that time it became known that the fixing of the engineered script was much cheaper than fixing the recorded scripts. So they took also that time down, and we can see, for example, that in the Laroline system, in the engineered scripts, you only used half of the effort that you needed for the capture replay system, and this was also consistent. So repairing is much cheaper with the engineered scripts, but the initial development is much cheaper with the recorded scripts. And basically the amount of repairs you have to do depends on the releases you do. So typically in every new release, new features are programmed, and some of the scripts break down and they have to be fixed or recaptured. So basically, as time goes on, there is some sweet spot that you get some initial. The overall costs of capture replay is cheaper in the beginning, but then the fixing cost starts to occur, and then at some point you have spent so much time in fixing that it would have been better to do the programmed scripts. So what this highlights is that with the engineered scripts, the initial investment is higher, but then you get benefits later. Whereas the recorded script, the initial investment is lower, but then over time the cost occurs. And in general, this is also true for test automation decisions. At first it might be cheaper to do manual testing, but as you do many releases and you need regression testing, then the automation starts to become more cheaper. So now we jump to the data-driven or parameter-sized tests. And the difference to the engineered scripts is that here the test inputs and expected outputs are stored as data, and they are separated from the scripts. So the test data and test out scripts are now separated. So they can be, for example, the test data can come from tabular format, for example. Here is a tabular inputs of standard hours, holiday hours, and a wage. This could be an input for a test case, and then the correct payment amount is also given in this tabular format, and then this will be executed by the test scripts. And this avoids the problem of embedding the test data to the script. So the test might be hard to understand with all the middle of the scripting details. So the actual tests are in the data. This is the idea here. This also solves the problem with the engineering scripts, where you have to create similar tests with slightly different test data. And this requires programming, and this can lead to copy-paste scripting, where you copy-paste the script just to have a little bit of different test data. So in this case, you don't have to do the copy pasting as the data is separate, and you just have a runner that executes all the test cases. Of course, the argument has also been made that the external test data can be edited without programming skills as well. So test data could now come from business people or customer and so on. But in practice, they probably still need help for that. But at least it simplifies the communication with them. You go and discuss, for example, the different scenarios and their outcomes in a tabular format, rather than having the whole test script with, the all scary looking programming details there as well. And this is also supported in JUnit, starting from some version of JUnit 4. So you could have utilized this in the previous exercises for this course that you did in the weeks 2 and 3. And what is going on here is that, okay, I will just go through the example. So parameter size test in JUnit. So this is a Fibonacci test, testing the Fibonacci numbers with different inputs. And here, this list is the input value and the expected value. So here is, if you enter 0, you expect 0. If you enter 1, you expect 1. And so on. So this is tests that the functionality compute the Fibonacci numbers works correctly. And here we can see that the test data is separate from the execution logic. And then what happens is that in the Fibonacci test, the input value comes here and the expected value comes here, and it is stored in f input and f expected. And the test is just one line of code then. So assert equals whether the expected matches the return value of the Fibonacci compute with the particular input. So the data-driven approach works in the JUnit. But you can also do it in Selenium, which is the web-based testing tool for system-level testing. And utilizing this data-driven testing, well, we can go back to the example that we had a few lectures ago where we tested the calendar field of Outlook. So we had boundaries for the month, day, and the year. And I realized there was some dispute what was actually the final date. So I think it was 1800, although I think there was some student that claimed it was 1601. But okay, so for the purposes of this example, I have fixed these boundary values for the year to be 1800. I'm still not sure if that's correct, but let's just leave it at that and go with this example now. So basically in the data-driven testing, this would be the test data, these test cases here. So test case number 1 would have data of day 1, month 1, year 1800, and the expected result would be okay. And then we would have the second test case, 31, 12, 2001, and then the expected result is also okay. So this would become a table, and then one could plug in, for example, the Selenium web browser that can be made to interact with Excel files, for example. And then it could execute with a simple script all of these different test cases. I mean, here we have 7, but to do indicates that there should be more. So this table could grow much larger. And this would be a way of separating the test data from the test scripts. And we have to remember that the number of these test cases would actually grow quite a bit when we would start also to test other fields. Now we only tested the date, but we should also test the title and location and so on. So these test cases would grow larger, and then having them having the test cases or the test data in a separate file would make sense, and then you would just have a runner that would go through the table, test this one, then test this one, this one, this one, this one, and then you could add more test cases by simply increasing the rows or columns in the table. And there is a YouTube video showing how to do data-driven testing with Selenium. I have linked it. You can watch it if you want to go into more details. Okay, so the next level is keyword-driven testing. And the idea behind these keywords is that they abstract the navigation and actions from the scripts. So previously the test data was read from an external source. So you had the scripts and you had some external data source. So with keyword-driven testing, this idea is extended also to the actions. So the actions are also read from an external data source. And when the test cases are executed, the keywords are interpreted by the test library, which is then called by the test automation framework. So the test library is actually the test scripts on bottom of all this that run the actual thing. And this improves the data-driven approach. So if we look into well, here is a hypothetical example of how it might work. So the test cases could look something like this. So you could say, login, admin, and then you would give the password. But notice that all the sort of dirty details on inserting the particular field or pressing enter are missing here. So you would have a keyword like login that would expect to have 2 parameters, and then the library would interpret this login keyword when it runs these tests. And the next word would be add customers, that would expect a data file. So this would be the keyword, and this would be the reference to the external data file. And another keyword could be remove customer, expecting 2 parameters, first name and last name. And in some way, the keyword-driven testing is very close to the idea of domain-specific languages, if you are aware of what that is. So just briefly, domain-specific languages represent the idea that the programming languages might not necessarily be at sufficiently high level. So you would create another language that's even on a higher level. And this might be useful for various industry domains. So you might have a domain-specific language for cars, or you would have another domain-specific language for chemical plants. And then this domain-specific language would contain concepts that are relevant to that particular domain. So here we have kind of like the same idea that you have these sort of higher level keywords that then are interpreted and run. And one important aspect is that you can define more keywords. Sometimes the keywords are also referred to as action words based on the existing keywords. And this is the one best such library, or one architecture of a keyword-driven framework. And we can see what happens here is that the test, when running tests, the test engineer invokes the user interface that then starts the test runner. And inside the test runner, there are keyword handlers that then take care of the actual test execution. So for example, one test library could be for interacting with Android phones. We could have another library that is ready to interact with web-based forms and is running on top of Selenium. And we could have a third library that is, for some domain-specific area, like cars, for example. And if you are looking for a keyword-driven framework, the robot framework is quite popular, also internationally. It's developed here in Finland, but it has a quite large user base, and many test automation companies are utilizing it for their work. So finally, we have model-based testing. The idea is that you model the system under test. For example, you use UML state machines to model a system. So the initial effort is creating the test model. And then the test cases are automatically generated from this model. Or it can also execute the system on the fly. So the more accurate your model of the system under test, the better tests you have. So they can generate large amount of tests that cover the model. There can be many different covering criteria for the model. I mean, similar types of, I mean, you had covering criteria on the source code level, but this would be covering of the model, of the test model of the system. So you try to cover all the edges, all the paths, and so on, but on the model level. Execution time for test cases might be a factor. The model can also provide expected results for the generated test cases. Yeah, there might be some challenges, especially with data-intensive systems. If it's suitable to use UML state machine, this might be a good approach. GraphWalker is quite popular tool for this kind of model-based testing. So I will provide a link for that in the course page as well. Okay, so now we have covered the 5 different types of test automation. So the evolution of testing approaches. So first we have the recorded scripts where you record your actions and play back. Then it's engineering scripts. You program and then those become the scripts. In the data-driven level, you separate the data from the actual scripts. In keyword-driven testing, you also start to generate higher level actions. So for example, login would be a keyword that would then actually log to some system, and the library would handle that. And then on the model-based testing, you model the test system, and the tests are automatically then generated as the test automation system just goes through the model. So from one state to another state to another state, back and so on.